test is an instant way that you can determine a converging function. And one of the students asked, how do I know what to compare to? This is very helpful. P is just a power of x in the denominator. So let's say we did 1 over x. What's the antiderivative of dx over x? Natural log of x, right? Going from 1 to infinity. So if you took the natural or the limit as n goes to infinity of the natural log of n minus the natural log of 1, what is the natural log of 1? 0? What's the natural log of infinity? Oh, it's infinity. So this is what we would call diverge. So if this is a 1, it's going to diverge. By the way, what would happen if it were a 0? You'd get 1 over 1. This would be x. What's the limit as you go 1 to infinity of x? Infinity. So that's going to diverge. How about negative 2? Now this turns into x squared. Yeah, none of those are going to work. So if we're keeping track here, and these are my p-values, I said that 1 doesn't work, 0 doesn't work, negative 1, negative 2, negative 3 doesn't work. None of these integers are going to work. But what about negative 2? Or what about 2? What if the p-value is 2? So this is going to be integral of x to the negative 2. What's that antiderivative equal to? Yeah, it's x to the negative 1 over negative 1, going from 1 to infinity. And this is going to be equal to negative 1 over x, going from 1 to infinity. And you guessed it, limit as n goes to infinity of negative 1 over n minus a negative 1 over 1. What happens to that 1 over n? Goes to 0. What if this were a 3 or a 4 or a 5 or a 6? All of those are going to work. So with the p-test, all of these, 2, 3, 4, and up, all of these are going to work. Okay? And as it turns out, how about like halves, like 1/2 or negative half, or all of these fractional powers? Those aren't going to work either. You could test them if you wanted to, but as it turns out, if p is greater than 1, they will converge. If p is less than 1, it's going to be, or equal to 1, it's going to diverge. Okay? You can certainly test it out, but if you saw 1 over the square root of x, what's the power of going from 1 to infinity? What's the power of that? X to the what? 1/2. Is that 1/2 larger than 1? No. So this one's going to diverge. You don't even have to look at. You don't have to look at it. What if this power were negative 1/2 or even negative 3/2? Nope, that's going to diverge. What if the power, and I've seen this on an IB test, I thought it was cute but kind of obvious. What's this one going to be? What's that? It's a little bit bigger than what? 1, so it's going to converge or converge.
But does it work?
Well, let's see. Let's see what happens. Let's integrate x to the negative 1.1, going from 1 to infinity. So what's that antiderivative? X to the what? Negative 0.1 over negative 0.1. And we're going from 1 to infinity. So let's see. And so you'll get negative, it's actually 1/10, so it's 10 over x to the point 1 going from 1 to infinity. So the limit n approaches infinity of negative 10 over, yeah, n to the point 1, right? And then minus a negative 10 over, and then this is going to be 1 to the point 1 is 1. Okay, so then this is going to go to 0, negative 10 over infinity, and this will be plus 10. So that converges. So all said and done, you take the integral from a to infinity of 1 over x to the p. P has to be what to converge? Yep, p has to be greater than 1. Excellent. Diverge? P has to be less than or equal to 1. Yep. Am I going to do this to you? Yes, I am. What about, you ready for this? Ready? You sure? You ready? X to the p. Turn to your neighbor. See if you can explain what's going to converge, what's going to diverge. Tell me, what is this one going to be? To converge, what's going to happen this time? P is going to be what? Less than or equal to what? Just less than negative 1. Why is that? Because, yeah, so if this were negative, then it would be 1 over x to the p, and that'd be fine. What's about diverging? What's this going to be? P is going to be what? Greater than or equal. So can we say that it's the opposite? Not quite. Not quite the opposite. These signs are opposites, but the equal sign is still with the divergent. So it's not quite opposite. I thought that was worth mentioning.